Hello students, continuing our lectures on mathematical physics. We will do some problems on beta and gamma functions in this lecture. So the first problem is if the gamma function, as we know, is represented in this fashion into 0 to infinity into the power minus x to the power z minus 1 dz, where z is greater than 0 and it's a real number. And if now we have to show that gamma z plus 1 is equal to z gamma z. So if we expand this, we can write it as the limit t tends to infinity 0 to t e to the power minus x square dx, replacing z by z plus 1, and so integrating by parts. Gamma z plus 1 is equal to limit t tends to infinity, it is minus x to the power z e to the power minus x 0 to t plus z 0 to t e to the power minus x into x to the power z minus 1 into dx, and it is again equal to z limit t tends to infinity 0 to t e to the power minus x to the power z minus 1 dx, and it is equal to z gamma z. So this relationship has been proved. The next one is we have to show that if z is a positive integer, then gamma n plus 1 is equal to n factorial. So what is the logic behind is that if t to the power z e to the power minus t tends to 0 as t tends to 0, t tends to infinity, and gamma 1 is also equal to 0 to infinity e to the power minus x dx, and it is also equal to 1. Now if z is a positive integer n, so we are replacing z by n, so naturally gamma n plus 1 will be equal to n factorial. So this is the second relationship proved. So a gamma function is an extension of the factorial function to numbers which are not integers. So we can write an important statement that the gamma function is an extension of the factorial function two numbers which are not integers. Two numbers which are not integers. Okay, so the second problem is 2 is know that the beta function bmn is given as 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx, and we need to show that bmn is equal to gamma m gamma n divided by gamma n plus n. This relationship we have to prove. So what we'll do, we will start with the substitution. That we will write x as equal to sine 2 phi. So using this, the beta function bmn can be represented as 2 into 0 to pi by 2 into sine phi to the power 2m minus 1 into cos phi to the power 2n minus 1 into d phi. Now we know that gamma n is equal to 2 into 0 to infinity y to the power 2n minus 1 into e to the power minus y square into dy. So we can write gamma m as equal to 2 into 0 to infinity y to the power 2m minus 1 into to the power minus x square dx. So gamma m into gamma n is equal to 4 into 0 to infinity x to the power 2m minus 1 y to the power 2m minus 1 into exponential minus x square plus y square dx dy. The double integral may be evaluated as a surface integral in the first quadrant of the xy plane. And now we will introduce the polar coordinates. So we will introduce polar coordinates, that is r theta. So we can write x is equal to r cos theta, and y is equal to r sin theta, and the surface integral ds is equal to r dr d theta. So putting these values in this expression, what we ultimately get is gamma m into gamma n is equal to 4 into 0 to pi by 2 and 0 to infinity r to the power 2m minus 1 cos theta 2m minus 1 into sin theta 2n minus 1 e to the power minus r square r dr d theta, and also this is also equal to 2 into 0 to pi by 2 cos theta. Take it out separate the two integrals into 2m minus 1 into sine theta 2n minus 1 d theta. This is for the theta part, and into multiplied by 0 to infinity r to the power 2m plus n minus 1 d to the power minus r square dr. So this part is nothing but okay. Now if you move back to where we started, you move to the expression of look to the expression of bmn once again. So this, you can see this relationship, this bmn, it is matching with this one. So we can call this one as equal to bmn, while as this one is simply gamma m plus n. So what we finally get is gamma n is equal to b m n into gamma m plus n. So that's how the relationship gets proved. Gamma m, gamma n, gamma m plus n. Okay, now the third problem says that use the beta function, use beta function to evaluate the definite integral, to evaluate the definite integral 0 to pi by 2 cos theta to the power r d theta. Now from beta function we know that like in the previous case, we know that bmn is equal to twice of 0 to pi by 2 into cos theta 2m minus 1 into sine theta 2 n minus 1 d theta. So here what we will do, we will put 2m minus 1 as equal to r. So that will make m as equal to r plus 1 by 2 and 2n minus 1 as equal to 0. So that will make n is equal to 1 by 2. So the beta function now becomes 0 to pi by 2 cos theta to the power r into d theta, and this is nothing but so we have r plus 2 and we have 1 by 2, and from the relation we know that this is gamma m gamma n divided by gamma n plus n. So in the same notion this becomes 1 by 2 into gamma r plus 1 r plus 1 by 2 for m and gamma 1 by 2 for r, and it is equal to gamma r by 2, that is r plus 2 plus 1 by 2, that will make r plus 2 by 2. So it will be r by 2 plus 1. So this is expression. Now gamma n, as we know, is equal to 0 to infinity x to the power n minus 1 into e to the power minus x into dx, and so we put x is equal to y square, and we have dx is equal to 2y dy, so that we have gamma n as equal to 2 into 0 to infinity y to the power 2n minus 1 into e to the power minus y square dy, and gamma 1 by 2 is equal to 2 into 0 to infinity to the power minus y square dy, and it is equal to 2 into root pi by 2, and it is equal to root pi. So we can write 0 to pi by 2 cos theta, that is the beta function, transform beta function to d theta, is equal to root pi by 2 into gamma r plus 1 by 2 into gamma r by 2 plus 1. So this is the value of the expected what has been asked for. Now the last question is question 4 is that we have to show that gamma n into gamma 1 minus n is equal to pi by sine n pi, where n is between 0 and 1, and we have to also show that gamma I n whole square is equal to pi divided by n sine n pi. So to continue that, let us say that so we start with the beta function. We know that beta mn is equal to 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx. So if we put x is equal to y plus 1 plus y, and we put bmn as equal to 0 to infinity y to the power n minus 1 dy into 1 plus y to the power m plus n is equal to gamma m gamma n divided by gamma m plus n. Now if we let m is equal to 1 minus n, where n is between 0 and 1, so we can have 0 to infinity y to the power n minus 1 divided by 1 plus y to the power dy, and this is equal to gamma 1 minus n into gamma n divided by gamma 1, and gamma 1 is equal to 1, so we have 0 to infinity y to the power n minus 1 divided by 1 plus y to the power dy is equal to pi divided by sine n pi, where 0 is between n and 1. This is the first relationship, and so gamma n, gamma 1 minus n is equal to pi by sine n pi. This is the first condition that has to be proved. The second one is gamma gamma I n whole square. It is equal to gamma I n into gamma 1 minus I n divided by minus gamma I n whole square is equal to gamma I n into gamma minus I n, and we know that gamma n is equal to gamma n plus 1 by n. So we use this relationship here, so we can write this one as equal to so gamma minus I n will equal to gamma 1 minus I n by minus I n. So using putting this value here, you can write gamma I n whole square is equal to gamma I n into gamma 1 minus I n to minus I n. And using the previous relationship, that is gamma n, gamma 1 minus n is equal to pi by sine n pi. Using this relationship also, what we finally get is gamma I n whole square is equal to gamma I n into gamma 1 minus I n divided by I n into sine I pi n. Further, we know that sine hyperbolic h pi n is equal to I into sine I pi n. So this will replace sine I pi n by sine hyperbolic pi n by I. So gamma I n whole square is equal to now gamma in into gamma 1 minus in divided by minus in. So we'll just replace it with this expression, that is sine h pi n divided by I. So this I cancels out, and what we are left is it should be actually pi, not, it should be pi here. That is already using this previous relationship, this one, so it will be pi by sine pi. So ultimately it is equal to pi by n sine hyperbolic pi n. So this is the expression of gamma in whole square.